So with that, I would like to introduce the next speaker, who is Professor Mohammad Patwary, who's a full professor of telecommunications and director of Center for Future Networks and Autonomous Systems at the Faculty of Science and Engineering and University of Wolverhampton from June 2020. He's also the research lead for 5G connected for the 5G Connected Forest project that aims at accelerating visitor economy in Midlands. Before that, he was a full professor of telecommunication networks and digital productivity and the head of Intelligent Systems and Networks Research Group at the School of Computing and Digital Technology at Birmingham City University between 2017 and 20. He was also the principal architect for a large-scale 5G testbed in the UK to accelerate digital productivity and develop urban connected community with West Midland. He was also full professor of wireless systems and digital productivity and the chair of the Center of Excellence on digital productivity in Stratfordshire until 2017. His research interests include intelligent and autonomous systems, wireless systems, future generation of cellular network architecture. With that, I'd like to give the floor to Professor Patwary, who will be talking to us about wide-scale 5G deployment set to reform telco business oligopoly. Actually, I should have made that a question. Is a wide-scale 5G deployment set to reform telco business oligopoly? Mohammed, take it away.
All right. Thank you, George. Can I ask you how much time do you have? Do I have?
We have 20 minutes, although we are running, I think, 5-10 minutes late. So if you can keep it between 15-20 minutes would be great.
Sure. All right. Thank you. Thank you, George. I'll just put my clock in. Well, thank you very much for inviting me. And of course, thank you for everyone who is here to listen to this kind of interesting talk. So if I give you some background into that, there are two test beds that I'm working with. The test bed in the UK, they're very different in the sense that we try to understand the real deployment kind of challenges in different settings. So what I'm going to do next 15-20 minutes, as much as it takes, that one of the studies that we have done, what are the kind of challenges that we find for 5G deployment in the UK's context. I'm sure it is almost the same into most of the other countries. Right, so interestingly, as I said, we work with the business school to find out what are the kind of business reform, especially for telco business, 5G deployment can make. So I hope at the end of this study, or the end of the presentation, you will agree with me what is coming. Right, so what I will try to give you certain background of our study, that why we looked into this and why it is important, then summarizing at least three different contexts of our study, and of course summarizing what is our findings. Let's see how far we can go. So this is the kind of starting point we had. If you look at telecommunications infrastructure stakeholder, rather, we identify four different stakeholders. First of all, we look into infrastructure providers. So as a general user of mobile phone, you can see a lot of masts. Not necessarily they're owned by the mobile network operator. They're owned by a certain company, and that particular sector, we call them Telco. And in the UK and most of the countries around the world, there are few limited number of Telco providers. And the word I've used in the title was oligopoly. It's not monopoly, but it is not open market either. It's quite limited competition they play into. I would say at the end of the presentation, it would be they used to play. Things will change, we'll see. So other than infrastructure provider, we have connectivity provider, as we see all the operators we have. So in the UK, we have four. We'll be looking into all of them. And whenever a user has set of connectivity, we do have connectivity dependent service provider. For example, Uber will not be successful if that user doesn't have internet access with that mobile phone. It's the same thing with Google or Amazon, any of this provider. So we identify them into this kind of social network where people can connect each other, or one entity get connected with others. And the last one is actually those kind of connectivity service consumer, which we are. Now, this is how the revenue flows, if you think. You can see that we, as a user, we spend most of the money. To maintain connectivity, we are giving money to the operator while we get connection of the service. And of course, the operator, they put money towards that, having access to those infrastructure, as it say, TowerCo. Using connectivity, the kind of service we wanted to have access to, that's another place we spend money as a user. At the same time, you can see, since it is a marketing platform, as you see, there's marketing campaigner, they put all the advert for the product. They are asked to do so. Now, this is traditional model, as you see. So users end up with paying two different directions, and those kind of connectivity dependent service provider, they end up with getting money from two different directions as well. Right. So what do we, so when we look into those challenges, we look into the infrastructure first, what is coming. Now, since the theme of this event is 5G, let's look at this 5G to different characteristics. When you provide connectivity with 5G, we can look into three different aspects, either high volume of data delivery or high device density, or nearly real-time data exchange. We are not sure whether we managed to achieve that yet, but theoretically, that's what we expect to provide. Now, when you look at the infrastructure, first of all, we need to see what kind of data rate that we need to support. With geographical region, we need to, I'm talking about the terrain structure we have to support, and which spectrum will be available to us. Considering all of them, we need to make a decision what would be the cell size. So you can see for three different services for eMBB or ULSC or MMTC in 5G, cell radius, it could be a variety of different radius you can think of. So that's into horizontal spread. Interestingly, the other thing we need to consider that how tall those infrastructures are supposed to be, because you'll be transmitting a certain amount of power. Those power may radiate some energy which will be harmful for the people, the living things on the ground. So ICNIR is the kind of governing standard that we follow, that which level of volts per meter or this kind of electric density that we can afford as human skin. So to think of here with the different spectrum, we have different tolerable EMF level. Now, if we consider 3.5 gigahertz, which is one of the preferable spectrum for 5G, we have that 61 volts per meter kind of EMF limits. Most of the time, we are transmitting significantly lower amount of power. So eventually, this is interesting findings that we have. If you take this into consideration, the safe distance to operate around that would be just 12 centimeters. Now, a lot of people around in normal society think of 5G will destroy skin or be toasted people around it. Operators taking 10 times bigger precaution into that. So taking that into consideration, standard distance between human head and to the mast where you'll be radiating power, minimum distance should be around 1. Operators maintains almost 1.2, 1.3 meters. Considering this would be the minimum distance, operator would be willing to do that. And also, the other things we need to think of, if we go for 5G infrastructure, depending on the amount of power and the height requirement you're thinking of, coverage requirement you're thinking of, you will see later that small cell will be the direction we need to move forward, where we need to look into indoor and outdoor, that very small radius of coverage. Right. Now, this is interesting. Like any other generations of network operations, 5G will not give blanket coverage around the country. It is specialized kind of service provisioning on top of or coexist with the rest of the other generations we had. Now, if we would have put 5G blanket coverage in the UK, then we would have needed almost 500,000 base stations in a very small country. Compared to the existing number of base stations, I'm talking about early 2020, those numbers around 40,000 existing base stations we had. So literally, we need to increase 10 times, okay? And putting this kind of new physical infrastructure is a challenge for so many different ways. We'll see that later. So if you go for small cell, because we have different range of power allocations, of course, we'll be talking about quite a small range of power. As I said earlier, maybe up to 2 watts will be generated from the base station. Now, theoretically, if you want to avoid this kind of bigger infrastructure deployment, we could have used something shared environment. What are the possible things technically we can do? We can share mast, we can share site, of course, radio access network we can share, we can provide roaming facilities, and of course, core transmission ring, and any other shared element within the network. It is theoretically possible. Practically, they are not interested, although we can save money, but the operator, they are not willing to do that. This is one of the biggest challenges that we've been struggling up until 4G. Now, few of the things that we try to recommend, I think worldwide is moving forward. We want to ensure we cannot have 500,000 base stations with a certain number of new infrastructure. The way we want to have access to this network will be coexistence or co-location of the shared resources. And there's a number of responsibilities we can share. So what we propose that is there any way someone can provide infrastructure without having any network operation interest? So that actual network operation interest, whoever has, they can borrow that. And this is why we call that kind of infrastructure provisioning to be neutral host. So quickly, I'll go through certain numbers here. When you look into this, we said we can upgrade some of the existing sites. So if I would have upgrades a macro cell, that would have cost me 120 or 121,000 pounds without sharing. If I would have put a massive MIMO, that kind of antenna, it would cost around 146,000 pounds. Now, not necessarily all the elements in the network, when you have shared this kind of site, we cannot share all of these elements here. So in this plot, I've highlighted some of the green items we can share. So if you have this kind of shared agreement, instead of having 120,000 or 21,000 pounds, with macro cell upgrade, we can do around 72,000 pounds. Now, this is where everything comes into our, where that if we really wanted to have small cell, and if you want to have either neutral hosting or some way, we can minimize cost. We think of having a street pole, street lamp, or street infrastructure. We can grow every single site to as low as 8,330 pounds. Not necessarily that each of these sites will give you exactly the same coverage. The conversion of this coverage between 1:5 or 1:8, that's the range. So if you go to 1:5 scenario, whichever area you could have covered with the upgraded macro cell, with 5 base stations, that will cost us around 40 to 42,000 pounds. So this is kind of infrastructure-related cost saving. Now, then we said if we are using those kind of street infrastructure, we need to understand the robustness of those kind of infrastructure. Again, looking at the time, I'll go through this few data here. What we discover that in our design, we are keeping that infrastructure to be up to 4 meters. Remember, I'm annotating some of the numbers. We said 1.2 or 3 meters between the height of the person to the antenna. Taking all the other into consideration, we said the height where antenna is supposed to be would be 4 meters. The existing infrastructure we have, the height is between 6 meters to 10 meters. So we can tick this box. The infrastructure has some mechanical design. It can carry some additional weight that should be up to, we need 7.5 kilo, but there is this tight scenario. Some infrastructure, they can take up to maximum 5 kilogram, up to 15 kilogram. If you put this infrastructure, the wind scenario, how much wind it can stay there, in the existing, we need 20 kilometer per hour, but the existing infrastructure can go up to 22 kilometer per hour with this additional weight, up to 10 minutes. Then after that, that will start deforming. And of course, we've been talking about the density of them and operations cost. We don't know, but the money operator wants to pay for each of these kind of sites around 70 to almost £1,000. I'll come to this recommendation later. Then what we have done in terms of deployment, we looked into suburban kind of areas like in this Aston Villa Football Club area and a dense urban area in Birmingham city centre. Taking for suburban scenario, we've taken 0.343 square kilometer. And for dense urban environment, we take almost 1 square kilometer. So what I wanted to, or our study found here in suburban environment, we needed 15 small cells to cover that, and we managed to find 15 public infrastructure, street furniture there. When you go to dense urban scenario, out of 80 cells required, we got 51 with the existing lighting columns. And so altogether, we had 60 public infrastructure from the road. And of course, we need to add 20 additional sites. Now, availability of this kind of infrastructure, let me go through this here. If you go to any traditional cities, there's a lot of street lamps you can find out, and a lot of public infrastructure. So here, these kind of brown dots, they are actually street lamps, and the purple dots, they are public buildings. So literally, there is an opportunity that local authority can provide infrastructure, and I'm sure it is valid for most of the countries in Europe and America. Going down to the changes here, just quickly here. Currently, we have mobile network operators, but at the same time, there are some mobile virtual network operators. This is because they do not have access to infrastructure or spectrum. Now, UK was one of the first country, I can say, that they released 5G compatible spectrum. 10 megahertz bandwidth you can hire with only £80. Remember, for every single base station that we do. And it has some constraint, but again, to have a private network, it is good enough. So what I want you to highlight from this particular provision that we can have access to spectrum. Previously, we said infrastructure could have been cheaper or easier. Now, if we have relatively accessible low-cost infrastructure and spectrum, we can see different kind of new generation of network operator will come. For example, in a warehouse, they can have their private network. To cover particular events, we can have micro operator they can run that business into. In small island, they can have use the infrastructure and have this kind of spectrum. They can have community network. So all of these three kind of network will be coming into the play. Now, so I'm just quickly going into this here. Now, if someone putting this kind of infrastructure, there should be a way to generate money. Now, one of the ways we can think of that, because of the infrastructure availability, data harvesting could be one potential business model. In the current architecture, we are not sharing data because of the standard. Of course, you can see the market is immature. What are we going to do with this data? It was not clear. I cannot say it is not clear now. It was not clear because we can use this data for AI. The data landscape was fragmented. People that would want to share data, and of course, if you want to share data, we don't know what are the kind of challenges we are going to get. So scale and competence was a challenge. Now, what we propose here that next generation network, whenever we come into play, every single household will get connectivity as free service from the local authorities. Although I say it's free, that is coming from the someone need to spend money, right? For the user's perspective, that could be free. Now, what we have done there at the moment, if you want to transform our society into digital, digital infrastructure-wise or digital provisioning, there are 4 challenges. People say, I do not have device, I do not have connectivity, I don't know how to use it, or neither of these device or connectivity is working. And that makes all the users to be using digital platform as a choice, not civic responsibility. So our study recommend, and of course input to the policy recommendation, that if we can solve these 4 challenges, we can make people having access to services in digital platform as civic responsibility, not by choice, because we guarantee everything is there. Okay, so what exactly we found here? Previously we said the current infrastructure, Telco is doing monopoly, but we discovered actually local authority can provide those kind of infrastructure to deploy 5G network. When you go to connectivity provider, we had national spectrum holder MNOs, but we can see if you have localized license, we can have new operator. It will be private network, community network, micro operator, or just because of the spectrum and infrastructure is available. And of course, the service provider, it has Uber, Amazon, Google that we've been talking about, that they're using our data without giving to anything to the user. But we think of there'll be a lot of object-oriented data harvesting small companies will coming up. They'll provide data as a service or decision as a service. From a user's perspective, the data, the behavioral data, or any kind of creative data they are generating, they're supposed to earn money out of it. Now, literally what will happen in that revenue flow, there is a change. If user allocate data as a service, social network, they're supposed to incentivize them. How? We need to agree. Right, and of course, mobile network operator, we can have new generation of network operator coming up. Local authority will be joining in here, but in terms of social network, there'll be competition coming into secondary network where they can generate federation of network. So summary into this series, I hope I'm on time. Right, sorry, 1 minute ahead of this. So what we found out, there's no other option other than infrastructure sharing in 5G deployment. And one of the way to avoid any kind of dispute, that should be neutral hosting provisioning. Local authority should provide the infrastructure in certain terms. And of course, if it is possible, active or passive kind of sharing, the operator is supposed to agree. Telco monopoly or oligopoly should be the biggest business that will be disrupted because local authority providing infrastructure. And mobile operator, they need to coexist with those kind of small operators coming up. And of course, data will be sold as a service or decision as a service as AI is taking our society into new direction rather, not different direction. And that's what we're learning. I hope I managed to share our learning. George, over to you. If someone has
Thank you. Thank you very much. Thank you very much for the great presentation, Mohammed. I think we have time for maybe one question. There are 3 questions in the Q&A. Maybe you can take the rest offline. So Professor Hong Wei Zhang asks, what's the transmission power and channel model that's used in deriving data in the coverage range? I think this was in the front part of your talk.
Right. So it was 42 ERP. It was 42 dBm. Okay. So making sure we are not interfering because the standard of the national operator, their transmission was 44 dBm.
Great. Maybe one more. Michael asks, since the number of base stations is so high for the requirement of 5G, could you do something like having a base station on every telephone / power pole? Like when a new pole gets installed, it would have your service transformer and then the base station radio requirements?
Correct. That's one of the main findings of our study. As I said in the figure, there are a lot of infrastructure like telegraph pole or the lamppost that we can share. So what we suggested in the UK's context, we have a lot of old telegraph pole, and at the same time lampposts, they are old too. And instead of having two, like telegraph pole, I'm talking about landline poles and street lamps, at the same time 5G base station together. So the design I proposed in the presentation, of course, I skipped in there. We merge everything together. Street lamp, 5G base station, and of course, telephone connectivity together. We have no other option other than doing that if we have that infrastructure available.
Thank you. Thank you very much, Mohammed. With that, we'll move on to the last talk for this session by Professor Hongwei Zhang. Professor Zhang is a professor